Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern County Water Agency, Southern California Edison, Kern Schools Federal Credit Union, and Panama Buena Vista Union School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Hi, I'm Marty, and I'm here at Bill L. Williams Elementary, home of the Pioneers, and we are here to...
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Mary Lou.
And I'm Chuck. Give us a call here. Our phone tutors are waiting to help you with your math here in Bakersfield at 636-4357. San Luis Obispo and the outlying areas, you can call toll free at 1-866-636-6284. You can email us questions at dothemath@kern.org. You can watch the show live online at dothemathonline.net. And you can look for us on social media. We're on Facebook and Instagram and Twitter and YouTube.
All right, well, you know what? We have a lot to get to today. We'll be going back out to Williams Elementary in just a little bit. But a reminder today and tomorrow, what is today, 23rd?
Yep.
23rd and 24th, the final 2 days for the 5th grade call-in contest. And we've got 3 schools right now that are kind of neck and neck. So if you're in one of those schools and you know some of your friends have been calling in from one of your classes, today and tomorrow, the final 2 days for the 5th grade call-in contest. But before we go back out to Williams and our first phone call, let's first take a look at today's Math in the News.
Feel it?
Well, today's Math in the News, we just felt a little bit of an earthquake right there.
I think so.
And I believe,
Yeah.
was it last Tuesday or Wednesday that there was one down here?
Yeah.
All right, well, you know what? We're still on air as far as I can tell, so let's keep it going. Today's Math in the News. Have you ever had a police officer show up at your door totally unexpected?
No.
No, neither have I. Chuck?
Yes,
What was
but not for us. They were like going through the neighborhood. I mean, they were.
Well, it's
going
funny
door to door.
because we got an email, you sent an email of a cartoon that I saw today also, and I clipped it out and cut it out and got it all ready, and I'm like, all right, well, let's just use the one on the computer here. So let's go ahead and take a look at the cartoon that was in the news today. So, police officer standing at the door. Hammy, we do not call the police for homework emergencies, but Dad, these fractions are killing me. Right, so of course, I mean, we saw this and we're like, all right, we
Absolutely.
have to put this on today. So, and down here, the reason we're using this one is because it tells you exactly what to do. Call Do the Math instead, right?
In homework emergencies.
Don't dial up 911, just call Do the Math. We'll take care of everything for you right there. So I figured, all right, well, we better figure out what we're going to do as far as
So if
Fractions.
you have
Yeah.
a
Right.
homework emergency with fractions,
right. And there are a lot of kids when they start doing fractions. Kids start doing fractions when they're in TK. They just don't realize all of the other things that are going to come along with it. So when they share something, you know, they're taking that whole and breaking it into parts, and then, you know, there's going to be however many times they're going to do that. But quite simply, fractions, we take a look at how many parts we have into how many parts it's going to be divided into. So the parts we have is the numerator. How many parts it's divided into is the denominator. And I think it was a 4th grade student last week that phoned in and needed to get an equivalent fraction. So a lot of times I know it used to be 5th grade where they would do fractions, decimals, percents, and they would spend a lot of time the entire year doing those. But it seemed like last week the 4th grade student called in with just getting equivalent fractions.
Right.
So equivalent fractions, we have 4/12 is equal to 2/6. But 4/12 is also equal to 1/3 if you simplified it a little more. But if we didn't simplify it, we expect, let's say, made it larger, we would see that 4/12 is also equal to 8/24, and there are a number of ways that you could find equivalent fractions for 4/12. Another way to quite simply make them larger is just add in 0 to each of the numbers also. But the fractions are equivalent because they describe the same part of a whole. All of the parts need to be equal as well. All right, because if somebody goes, hey, you know what, I'm going to give you part of the paper, well, if you cut it in half, both parts are equal, but if you go, I'm going to give you this little tiny piece of paper, and I'll get this, the parts aren't equal anymore.
Right.
All right.
Or
Yeah.
cutting a pizza into
Yep.
12 pieces or
Right, you
6
want to make sure
pieces.
that they're all the same.
Right.
Yes.
All right, and that is today's Math in the News. And you know what, it was kind of, I mean, because last week I didn't feel that earthquake at all when we were
No,
here.
no.
I felt that one.
Yeah. Oh, yeah.
Yeah.
And yeah, I mean, it's not like we're on the ground either
No.
here on this. Anyway, we'll go to the phones right now. And Laura, how are you today? Hello, Laura.
Hi.
And you're a student in 6th grade, correct?
Yes.
All right, as soon as you're ready, let's hear the math problem that you're working on.
Okay. Courtney visited her grandmother. Her grandmother used to collect stamps. She had a shoebox full of 5-cent, 6-cent, and 7-cent stamps. Courtney thought, I could mail a lot of different sized letters and postcards with these stamps. She tried to figure out the different amounts of postage she could make with a combination of those stamps. What totals could she make, and what totals are impossible?
Okay, Laura, so we have 5 cents, 6 cents, and 7 cents, correct?
Yes.
And so we're trying to find out different postage. So we need 3 stamps, correct? So every time she goes in and like pulls out 3 stamps. We're going to start with our combination of 5s first.
Okay.
So say the first thing she does is that she pulls out a 5 cents, a 5 cents, and a 5 cents, okay?
Okay.
Which we have 5 and 5 and 5, which gives us how much money?
15 cents.
It gives us 15 cents, correct?
Yes.
Then I'm going to stick with my 5s first. I'm going to start with the 5, 5.
Okay.
Then we have a 5 and a 5 and a 6,
Yeah. Okay.
which gives us 16 cents, okay?
Yeah.
Then we have a 5 and a 5 and a
7.
7, and that's going to give us 17 cents, okay?
Okay.
So now let's go to our 5 sixes.
Okay.
So we can pull a 5, a 6, and
And
a
a-
5, but can I do that? A 5, a 6, and a 5?
No.
No, because what does that equal?
16 cents.
16 cents, and we already have 16 cents, don't we?
Yeah.
Yeah, so we're going to get rid of that.
Okay.
Let's go ahead and do a 5, 6, 7. Can we do that one?
Yeah.
Yeah, and how much money do we have there?
We have 18 cents.
We have 18 cents, okay? And then we can do a 5, a 6, and a 6, which
Okay.
gives us how much money?
17. Yeah, 17.
Does that give us 17 cents?
Yep.
But we do have a 17 cents here. However, so does it matter if we have two 17 cents
You can
with
have two
different
17s because
but-
you have a different
Okay,
setup of.
combination. Yeah.
Right.
Okay.
So that one's okay because even though this one is a 17, these are different combinations, aren't they?
Yeah.
So that is okay. So I think we're done with our 5 sixes there, yes?
Yeah.
Okay, so let's go to our 5 sevens. So we can't really do a 5 7 6 because we already have a 5 7 6, don't we?
Yeah.
And we can't do a 5. Can we do a 5 7 5?
No.
No, because we have a 5 5. We have that already. But can we do a 5 7 7?
Yes.
Yes, and that gives us how much?
It gives us 19 cents.
That one gives us 19 cents. Okay, so what else are we possibly missing? Can we start with our sixes to see if we have some sixes that we can do, don't we?
Yeah.
So what about our 6, 6, and 6?
Yeah, you can do that.
Yeah, it gives us 18 cents, right?
Yeah.
Can we do a 6, 6, and a 7?
Yes.
Yeah, we don't have that yet, do we?
Yeah.
No. So we have how much money here?
For the 667, we have
Is that 19 cents?
what?
The 667?
Yeah.
Okay,
We have 19 cents.
that's 19 cents. Laura, do you think we could do any more with the 6s? Because we have the 6 by 5 there. Do we have a 665? Yep, we have
Yeah.
that already. So I think that might be it with those.
Okay.
Let's go to our 7s. Again, we could do 7, 7, 7, which is the easiest, right?
Uh-huh.
Which gives us our 21 cents.
Okay.
And do we have a 775? Nope, we can do a 775.
Well, you've got a 775 right at the top of that
Oh, I
column.
do. Thank you. I do. We have one right there. Do we have a 776?
Yes.
Yep. No, we don't.
Okay.
I don't think we have a 776.
Yeah, we can do.
Yep, which gives us 20 cents. Yes?
Yeah.
And so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What other combinations can we do?
We can do.
I think that might be it.
Yeah.
Well, let's see, what's
there-
the
are
least,
we-
what's the least you can have in stamps? It's 15, right?
Right.
And what's
That's
the
our
most
least.
you can have?
Our most should be our 21.
And do we have everything in between?
Yeah, I think, let's see, we have our 15, 16, 17, 18, we have 19, 20, and 21. Is there any more?
So
I
those
think
are gotta
that's
be,
might about
those are all
it.
the amounts. I don't know if you can get any other
Nations
combinations,
from
but
it.
those are all the amounts,
1,
right?
2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 combinations.
Okay.
So I
Looks
think
like
that's
that's it.
about it. That's about it, Laura, okay?
Great problem right there.
Good,
Laura,
yeah.
you still online with us?
Yeah.
All right, well, you know what? Since that was such a wonderful problem, we're going to send you home with a free movie ticket, courtesy of our friends at Maya Cinemas. So congratulations on that.
Thank you.
You're welcome. We do have phone tutors available until 5:30. Do you remember your elementary school?
Yes.
Yes.
Was it here in town or?
No, up in the Bay Area.
Okay. Was yours in town or?
Nope, down in LA.
All right, well, mine was in New York, so none of us can
All
remember
over.
going to school around here. Anyway, one of our associate producers, Mackenzie, is at her elementary school today, which is where they're at Bill L. Williams. Let's head out to the home of the Pioneers with Marty.
Thanks, Mike. I'm here at Bill L. Williams, and I'm here with Esmeralda. How are you doing?
Good.
Good. She's excited. We're all excited. We're here to do a math problem, one of her homework problems. She's actually multiplying fractions. So, Esmeralda, up here on the board, we've got 4 times 1/2, right? So I'm going to have you show me how your teacher did it and see where we go from there and if there's a different way to do it possibly. But what did your teacher show you to do?
So we can't multiply a whole by a fraction, so the teacher said just put a 1 at the bottom,
Okay.
and then you just start multiplying. So 4 times 1 is 4.
Uh-huh. So you did the top, so 4 times the 1 on the top is 4, okay?
And 1 times 2 is 2.
Is 2, so you get 4 over 2, right?
You can't leave a improper fraction like that, so you
Well, you can, but it's frowned upon in elementary school, yes. Okay.
so you have to divide 4 by 2.
Okay.
What equals 4? That's 2. 2 times 2 is 4.
And it goes in there evenly, right? So how many times does 2 go into 4?
2 times
2 times. So what's your final answer?
2.
2. So go ahead and write that over here. Circle it nice and big. Beautiful. Now let me show you a different way how to do it. So your teacher said that you can't multiply a whole number by a fraction. You technically can, but it's kind of tricky. So it's not too bad, but let me show you. All right. So here's what I'm going to do. Do you know what multiplication is? Like if I go 4 times 2, right? So if I go like 4 times 2, what is that?
8.
8, right? And how did you get 8? What did you actually do to get 8? Besides memorize it, what did you do?
You multiply 4 times 2.
Yes, but what is multiplication then? What are you actually doing? So this is what I like to think of. When you have 4 times 2, basically, don't you have 2 4s that you're repeatedly adding? So isn't this like 4 plus 4? Right? Or you can have how many 2s? How many 2s would you actually add up? What are you multiplying 2 by?
You're gonna
How many 2s? So 2 times 4, right? So what if I put 4 of those? What is 2 plus 2?
4,
Plus 2
6,
plus 2?
8.
So isn't that still 8? So isn't multiplication just repeated addition, right? But here I'm multiplying 4 times a half. So I'm going to draw a half. So isn't that a half? And how many of these do I need to draw though? I have a half times 4. So how many halves do I need?
4.
4. So here's 1, right? Here's 2. Here's, I got to draw another one, right? There's 3 and there's 4. So how much do you have?
4 holes.
But how many holes do you have? You have 4 halves, right? But isn't that 1 whole pizza? And that's another whole pizza. So how many whole pizzas do you have?
2.
You have 2. So that's another way you can do the problem. Like you can just add up that many halves, but that's kind of crazy, right? Because now let's look at your next problem. So let's see here. Let's erase all this. This is craziness. So your next problem was 22 times 5 over 11. Now if we thought of my way, right? We'd have 5 11ths, which is really crazy to draw. I have to cut this up into 11 pieces. So I don't know, like that. Is that 11? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11. There we go, 11. That's a terrible way to draw 11. But how many would I shade?
5.
1, 2, 3, 4, 5. And how many of these would I need to draw, though?
22.
22 of them. Wouldn't that, like, take forever? So this way makes sense, but it takes a long, long time when you have, like, big numbers.
number.
Yeah, that you have to actually multiply by. So why don't we go ahead and do it your way that your teacher said. So take your 22. Put the 1 over it. Beautiful.
22 times.
Sorry, times. I'm doing the high school times. The elementary times is little eggs, huh? Sorry.
22 times.
Good. You're multiplying 22 times 5. 10. Good. 11. Beautiful. You get 110 over. So you got 110 because you went 22 times 5, the tops, right? So what are you going to do now?
You have to divide.
Okay, so you got 11. Well, I didn't see you put the 11 there. You're pretty quick. 1 times 11 is the 11, right? So the question is, does 11 go into 110, right? So you're going to divide that. Okay, go ahead.
10.
Oh, there we go. So how many times does 11 go into 110?
10.
So what's your final answer?
10.
Throw it up there. 10, put a big old fat circle around it. And I would get the same answer if I added 5 11s plus another 5 11s plus another 5 11s plus another 5 11s 22 times. I would end up with 10 as well. Nicely done, Esmeralda. Beautiful. That's how you multiply fractions, the cool way or the crazy, like drawing the pie chart way. Back to you, Mike, in the studio.
All right, thanks for that, Marty. Let Esmeralda know that her name is now entered into that drawing for the 4-pack to go see the Bakersfield Condor. So hopefully she can possibly get that at the end of the program today. 636-4357 is the phone number. We do have phone tutors available until 5:30 on most Tuesdays and Wednesdays. Also a reminder, today and tomorrow, the final 2 days for the 5th grade call-in contest. And after tomorrow afternoon, we'll find out the 5th grade that we'll be visiting. And the young lady right now calling from one of the schools that's in the running. Caitlin, how are you today?
Hi, I'm good.
Good, and you're at Noble. I know that Noble is in the running. What grade are you in?
I'm in 5th grade.
All right, well, hopefully one of your classes is right up there. So as soon as you're ready, Caitlin, let's hear that
Yeah.
math problem.
Okay, Kate.
My math problem is 2 3/8, it's a fraction, times 4 2 6.
2 3/8. And the other one was 4 and. What was the
What?
other? What was the other fraction? Caitlin,
Yeah.
I got 2 3/8 times
2
4
3/8
times
times
4 and
4 2 6.
2/6.
Yeah.
Okay,
Times 4 2 6.
4 and 2/6, right? Mixed numbers.
Yeah.
Okay, so we know that to multiply these two mixed numbers, we have to multiply fractions, don't we? So we've got to change each one of these mixed numbers into a fraction. Now they're going to be improper fractions, aren't they? So what do you do with 2 3/8 to make it an improper fraction? Do you remember? So we're going to change that. We're going to change that whole number 2 into fractions, right? And we're going to do that by multiplying the 8 on the bottom times the 2, the whole number 2. So that's going to give me 16, isn't it? So 8 times 2, that's going to be 16.
8 times 2 is 16.
16. That's going to be 16 eighths plus the 3 that we already have. Okay?
Yeah, that equals 19.
So that's going to be 19 eighths. So what we did was we took 8 times 2 and got 16 eighths and added that to the 3 eighths that we had. Now you don't normally write this down, but that's what we're doing, okay? 16 eighths plus 3 eighths is 19 eighths. And we'll do the same thing with the 4 and 2 sixths, okay? We're going to go 4 times, or 6 times 4, that's going to be 24, isn't it?
Uh-huh.
Plus the 2 that we have is
That
going to
would
be 26 over 6, isn't it? Because that's 24 sixths plus 2 sixths. Okay? So we don't need these, but that's where we got the 19, and that's where we got the 26, isn't it? Okay?
Okay.
All right, now, do you, in your class, in your math book, do you multiply and simplify, or do you simplify first?
You multiply across?
Okay, we multiply across and get an answer out of here, but do you want to reduce before you multiply or after you multiply?
After you multiply?
Okay, let's try after.
Well, it sounds like she's not sure if you do it
Yeah.
before or after. How about if we do it before, just to make things easier?
We've got
Okay.
these 2 pretty big numbers. We got 19 times 26, isn't it? Right? So that's not something I want to try to do in my head. So let's see if we can do any simplifying first, because I know that I've got a 19 and a 26 on top, whatever that is when I multiply it, and I have an 8 times a 6 on the bottom. But you'll notice when you write that down, 19 times 26 on top and 8 times 6 on the bottom, that something's going to reduce, isn't it? You notice that a 26 is an even number and 6 is an even number, isn't it? So I can take 26 and 6 and divide them both by 2, can't I? 2 goes into 26 how many times?
26 can go into 19.
2 divides into 26 how many times? 2 goes into...
12.
Well,
12 times?
Well, 2 goes into 2 once, and 2 goes into 6 how many times?
3 times?
3 times. That's going to be 13, isn't it? And 2 goes into 6 on the bottom 3 times. Now let's see. I've got a 3 on the bottom and an 8 on the bottom. 3 doesn't go into 13, and 3 doesn't go into 19. I've got an 8 on the bottom. 8 doesn't go into 19 or 13, so it looks like that's about all of reducing we can do. So it looks like I'm going to have to do some multiplying. What's 19 times 3? Excuse me, 19 times 13 on the top. So what's 19 times 13? Let's go ahead and do that.
19 times 13 is...
So I'm going to put the 13 on the bottom. And what did we get? Did you get an answer?
247?
247. So that's going to be 247 on top. And 8 times 3, that's easy. I'll do that. That's 24. So it looks like our answer as an improper fraction is going to be 247 over 24. But we can't leave it that way, can we?
No.
Can't leave it as an improper fraction. So let's do the division. I'm going to take 247 and divide by 24. Well, actually, that's not so bad, is it? How many times does 24 go into 247? Well, 24 goes into 24 once, doesn't it?
Yeah.
But 24 doesn't go into 7, does it?
No.
So that's going to be 10, right? So 24 goes into 247 10 times. That's nice. And what do we have left over? Looks like we're going to have a 7 left over. And that 7 is going to go on top of our fraction. And the bottom, the denominator, is going to be the 24 we divided by. So it looks like our answer is going to be 10 and 7/24. Okay, you got that? Thanks for the call.
Nicely done. 636-4357 is the phone number. We do have phone tutors available until 5:30. Right now, we've got a problem for you, Mary Lou.
Okay.
Mick is going to use a $100 bill.
Okay.
Nice.
Do you
Where'd you
have
get a $100
an occasion
bill?
to see a $100 bill every once in a while?
Very seldom am I allowed to touch $100 bills.
He's going to buy 2 books,
Okay.
and each one of those books is $12.48.
All right.
2 videos,
Okay.
and each one of those is $13.89.
All right.
And then a variety of supplies that will cost $23.42.
$23.42. That's the total cost for all that other, right?
Right. And the tax is 6.5%.
Ah, 6.5%.
The question is, what will he get back from the $100?
Okay, so we need to find out what he has left over from the
Correct.
$100. Okay, the first thing we want to do is find out these 2 books. And what was the other 2? Was it video games?
Yes.
Okay, so the books and the video games, how much they cost before we can start adding all this up. So real quick, we're going to do some multiplication. We have 2 times 48. So that's our 16, our 9. We have our 4 and our 1, obviously. 2. There we go. So our books are going to give us a total of $24.96. And let's go ahead and do our video games, which is $13.89 times our 2. So we have our 18 and our 17 and our 7 and our 2, which comes out to be $27.78. Now we want to add all of this up before we start with our tax. So let's line this all up nice and neat, because a lot of times when we're dealing with decimals, if they're not lined up, then we're going to get off a little bit. Okay, starting with our ones column, we have 10 and 6, there's our 16. We have 10, 17, and that's a 21. Bringing our decimal point down, we have 10, 14, and 16. And then we have 2, 4, 6, 7. So our total comes out to $76.16. Now we need to apply our tax. Our tax is 6 5/10%. Now our tax is what's considered an increase, so it's a markup of our price. So our price is considered our total amount. This is 100% of what I'm going to pay. On top of my 100%, I'm adding 6.5% to that. So what I'm going to do is I'm going to take my 76 and 1600ths, and I'm actually going to multiply this by actually 106 5/10%, because I added the 100%. The 100% represents my value, total value. There's my 100%, and in addition to the 6.5%. I want to take this and I want to change it to a decimal. So I'm moving my decimal point over 2 times. So my decimal I'm going to be using will be my 1.065. Oh, let's redo that. So we have our 76 and 16, and we're going to multiply that by 106.5. So we got some multiplying to do here. Let me pull that down a
Well, you
little
moved
bit.
the decimal down the bottom. but
Oh,
you
I moved
the-
it here.
yeah,
Yep.
there you go.
Thank you. Fix that real quick. So we have 1.065. And again, we're going to need to multiply that out. So we have our 30, there's our 8, there's our 30 again, and then that is our 38. And we have our 36, 9, our 36 again, 42, 45. Add our 2 zeros, and actually add 3 zeros because of that 0 there. We'll start with our, oh, where did that just go? Let's just bring that right back.
You just threw that away,
Yeah, I threw that away.
but you caught it.
6, 1, 6, and 7. And hopefully you guys are checking all this, that I'm doing this right and not missing a step here. That's our 20. There's 8, 9, 10, 11, 11. 8, and we have to move our decimal point over 1, 2, 3, 4, 5 times. So 1, 2, 3, 4, 5. And it's looking like it might be about $81, and I'm going to round this to 11 cents because of the 9 in our thousandths place value. I need to round that up. So my total that I'm going to be paying is $81.11. I now need to take my $100 and I need to subtract my $81.11 from that. And obviously there's a 9, we have an 8, we have another 8, we have a 1, and it looks like we have $18.89 that we will be getting back.
Excellent job right there. Nicely done. 636-4357 is the phone number. Phone tutors here until 5:30. Final 2 days of the 5th grade calling contest. We'll be back with more right after this. Well, today we're at the Bakersfield Museum of Art, and with me today I've got Sarah, a student from Reagan Elementary. How are you today?
Good.
And with us we have Liz. And Liz, what is your title here at the Museum of Art?
I'm the education coordinator here.
So we've got the perfect person.
Absolutely.
All right, first of all, before we get into the piece that we're looking at right now, how long has the Bakersfield Museum of Art been operating?
We've been here since 1956.
Wow, 60 years. This is
Yeah.
a lovely facility. Has it always been here?
It's always been here. We did have a large expansion in 2001 that was completed in 2001. It was a much smaller building before.
Okay, and if somebody wanted to come visit the museum, when is it available?
We are open Tuesday through Sunday, Tuesday through Friday from 10 to 4, and Saturday, Sunday from noon to 4.
Okay, well obviously we're here for Do the Math, and we want to see how math applies to art a little bit. So Sarah, we're right here, and let's find out from Liz what we're looking at.
Okay.
So this is a piece by an artist named Kuzana Og. And as you can see, she uses a lot of rulers and shapes
Yeah.
and traces a lot to make sure that all of her shapes and lines are very straight.
Yeah.
And so I thought this would be an interesting piece because it shows a lot of geometric shapes in it.
Yeah. I want to know like how the artist can decide how big the painting should be to make it appealing, and how many shapes to make it appealing.
Great questions. Artists put a lot of thought into how large a piece is. Some artists will create works that are giant, as big as a building, and some artists will create teeny, teeny, tiny works. And that depends really on what the artist is trying to say. So these are aerial images of oil refineries and oil and water plants. So you can see some of the roads and some of the buildings that she might have taken some of the inspiration from. And this size was really, if she went much bigger, it might tell a different story. And if she went much smaller, it might tell a different story. So this was the ideal size for her work.
Okay.
Yeah.
Cool.
And then, as you can see, she uses a lot of shapes and colors in her
Yes.
work as well. And artists will use a lot of different tools to allow you to see the whole piece. So when you see these pink squares,
Yeah.
your eye goes from these pink squares up to these pink circles because they kind of connect.
Yeah.
And so she's using those two colors to allow us to see the whole piece.
Yeah.
Yeah.
Now Sarah, I know that you like this piece and you were asking about the size of it and things like that.
Yeah.
So scale is one thing that an artist has to take into consideration based on the medium that they're using sometimes.
Yeah.
Looking at this piece of work right now, how many different shapes can you find up there? Why don't you name them off and kind of point to whether you see them?
There's 4 triangles right there. There's some rectangles, some squares. There's some circles too.
And you were talking about lines, so you can see that the lines, so some of the roads and things like that, and then you got some of the different lines where they're a little bit curved and things like that.
Yeah. So she uses a lot of very straight lines, and then she makes it a little playful with these lines that kind of look like ribbons. They
Yeah.
kind of bring your eye around a little bit more.
What do you like the best about this piece, Sarah?
I like how the lines, they're like one section's going one way and that's going one way. I like how it makes your eyes kind of play with the painting.
Well, like Liz was saying, it kind of plays with the painting a little bit, but it also makes you follow it all the way around as well, right? So the movement aspect of this piece of art is something that she obviously was intending on, right?
Oh, yes, yes. And she has a lot of texture in here that these lines that she created look like they're very textured, but they're very flat. But they still allow you to kind of move your eye through.
Yeah.
All right, well, I know you've got some other art pieces that have to do with math, so let's go check those out.
Absolutely.
All right, let's go, ladies.
I think that's what really makes it interesting. I think if it was just lines going all over the place, it would be interesting for different reasons. But having that definite end and beginning, it really makes these pieces make you stop and think.
And if you've not yet had an opportunity to visit the Bakersfield Museum of Art lately, you need to make it a point. It's local, it's right downtown, and a wonderful resource to learn a little bit more about the arts and the different exhibits that they're able to bring into downtown Bakersfield here. We do have phone tutors available until 5:30, and right now we'll go back to the phones. And Andy, how are you today?
Nick spent one. Hello?
Yes, how are you?
Good.
Good.
You?
Hold on, before you get started, I need to find out a little bit more about you. You're at Noble Elementary, correct?
Yes.
And you're a 5th grade student.
Yes.
Okay, and what class are you in? Whose class are you in?
Miss Cass.
Okay, because I know that it's getting pretty close on these phone calls from the different classrooms. And anyway, we'll put down a tally for your class mark and for your classroom for the 5th grade contest. Andy, now let's hear the math problem.
Okay. Nick spent 1/3 hours doing homework. Of that time, 2/3 was spent on social studies project. How many hours did Nick spend working on the project?
Okay, so he spent 1 3/4 hours, right?
Yes.
And two-thirds of the time was on social studies?
Yes.
Okay, so what we want to do in this problem is we want to take that number of hours, that 1 3/4 hours, that's the total number of hours, but we only want 2/3 of that, correct?
Yes.
So we're going to take 2/3 of 1 3/4, which is the same as saying 2/3 times 1 3/4, okay?
Okay.
So we're going to take of means multiply. We're going to take 2/3 times 1 3/4, and that's going to be the number of hours he's worked on the social studies project. Is that what you said?
Yes.
Okay, so what do we do with multiplying a fraction times a mixed number?
We see if the denominators are the same.
Well, if we're going to add or subtract them, we need to be careful to do that. But in multiplication, one of the things that makes it a little bit easier is we don't need a lowest common denominator. But what we do need is we need 2 fractions, right?
Yes.
So let's take that 2/3, which is already a fraction, and we got to make that 1 3/4 into a fraction, don't we?
Yes.
So how do you change 1 3/4 into a fraction? And we know it's going to be an improper fraction, right? But what do we do with that 1 3/4 to make it into a fraction?
Multiply?
Yeah, we're going to multiply. We're going to do 4 times 1 because that 1 is a fraction. We could write 1 as 4/4, couldn't we?
Yes.
And we're going to add what we already have as a fraction, which is the 3/4. So we're going to do 4 times 1, that's 4, plus the 3 we already have is?
7.
4 times 1 plus 3, that's 7. And the bottom number, the 4, stays a 4. So we know that 1 3/4 is the same as 4/4 plus 3/4, isn't it?
Yes.
That's where we get our 7/4, and we just did a little shortcut, right? We just went 4 times 1 plus 3, and that's where that 7 came from.
Okay.
All right, let's do our multiplication. Now, I'll ask you the same question we asked one of the other callers. Do you want to multiply first and then reduce, or can we reduce first?
Multiply first, then
Okay,
reduce.
so let's do that. So on top, we're going to get 2 times 7, right?
Yes.
Numbers are much nicer in this problem. And on the bottom, we're going to get 3 times 4, which is nice. That's just 12, isn't it?
Yes.
So it looks like we're going to get 14 over 12, right?
Yes.
Okay, now what? We have an improper fraction, don't we?
Yes.
So I'll ask you a question again. Do you want to change this to a mixed number first and then reduce it? Or do you want to reduce it first?
I want to make it into a mixed number, then reduce it.
Okay, so mixed number. How do we change 14/12 into a mixed number?
Well, we could keep it, change it, then flip it.
Well, we're going to change it to a mixed number, right? And
Yeah.
we've already done the multiplication. So what does 14/12 mean? Do you know what that fraction bar means?
14/12 could mean that.
So I'm going to take the 14, and that means divided by 12. All right? So I'm
Yeah.
going to take 14, and I'm going to divide it by 12.
14 divided by 12.
Yeah, so 12 goes into 14 how many times?
1.
1 time. That's your whole number. And what's our remainder down here when I multiply 1 times 12 and subtract?
Our remainder is probably
14 minus 12 is
2.
2. So our remainder is 2. That's going to give me a fraction up here of 2/12 because 12 is what I divided by. So it looks like our mixed number is 1 and 2/12. But what's 2/12 reduced to?
What happened?
Can you reduce 2/12? Will anything divide into both 2 and 12?
No.
Well, they're both even numbers, aren't they?
Yes.
So what goes into every even number evenly? Let's divide by 2, okay?
Okay.
2 divided by 2 is 1. 12 divided by 2 is 6. So it looks like we're going to get the whole number 1, right? And our fraction reduces to 1/6. And we go all the way back to the original problem. You said he's going to spend 1 3/4 hours, right? So it looks like our answer down here should be 1 1/6 hours working on that social studies project. Okay?
Okay.
Thanks for the call.
Nicely done right there. Final 2 days for the 5th grade calling contest. Right now, we'll see if Marty has a 5th grade student. I'm not quite sure who she's working with right now, but let's go back out to Williams and Marty.
Yes. How you doing, Mike?
Good.
All right, we're
And
here.
who do you have
Sorry.
with you?
I have Samantha here with me, and she's actually in 6th grade.
Oh,
so-
that's why I was wondering if it was a 5th or 6th grader.
Yeah, she's a 6th grader. This is Samantha. We're going to do a problem that she's working on now in 6th grade. So, Samantha,
Yeah.
we've got a problem here written on the board. You've got a minus 1 equals 70.
Yeah.
And then it's asking you to test to see if 71 is a solution, right?
Yeah.
So it gives you 71, and it wants you to see if that's actually the solution to this equation. So what are you going to do here?
Going to replace the A with 70.
And what's a fancy word for replace? You know the fancy math word?
No.
Starts with an S. Substitute. You're
Oh,
going to
yeah,
substitute
substitute, yeah.
71 in for A. Okay, so you substituted 71 in for A, and so everything else is the same. You've got A is 71, but you still have the minus 1, you still have the equals, and you still have the 70.
Yes.
Okay, so now what are you going to do?
I'm going to see if this is equivalent. Not equivalent.
Yeah, that's right.
Yeah, equivalent to.
You're going to see if this side is equivalent to this side,
Yeah.
right, of the equation. Good. Go ahead.
And it,
What is 71 minus 1?
70.
70.
Yeah.
So it's so easy that it's difficult.
Yeah.
So what are you going to put here on this side?
Equivalent.
No. Well, what's 71 minus 1?
Oh, 70.
70. And what does it equal?
Equals to A equals 70.
So 70 equals, oh, don't put A, because A is 71. So you erase A. So but 70 on this side equals 70 on this side.
Okay.
So does 70 equal 70?
Yes.
Is that a true statement?
Yes.
So what does that mean about A?
That is.
So were we right? Is this a solution?
Yes,
Yes,
it's a
there you go.
solution.
So you would say here, your final answer is A equals 70, 71 is the solution. To the what? How do we sound fancy? To the equation. Is the solution to the equation. Nice full sentences. S-O-L-U. There we go, close enough.
Yeah.
I-O-N. Solution to the equation. Yes, I'm going to make you write it the whole thing because it's amazing. And English and math are connected. E-Q-U-A-T-I-O-N. Perfect. There we go. All right, the next one you have, what's the next one like? The next problem you've got. It's right here. I'm going to go ahead and read it to you. It's a word problem, isn't it?
Yes.
And those are your favorite, aren't they? Yes.
Yeah.
Yes, those are your favorite.
Yay.
Okay, here we go. I'm going to read it to you. I want you to write down the
Okay.
important information that you have from it. Terrence needs to score 25 points to win a game. He has already scored 18 points. Then it says the equation 18 plus p equals 25 gives the number of points p that Terrence still needs to score. So the question is, determine whether p equals 7 or p equals 13 is the solution of the equation, and tell what the solution means. So it's giving you 7 and 13 as possible solutions. So which one are you going to test first?
7.
Let's test the 7. Okay, so what's the fancy word you're going to do right now?
I'm gonna substitute.
You're going to substitute. Perfect. 18 plus p, which is 7. Yeah.
Yeah.
Beautiful. Equals.
No.
Yeah, on this side. So you're just going to carry this 25 straight down. Okay, so what are you going to do on this side? Can you simplify 18 plus 7?
No.
What is 18 plus 7?
Oh, 18 plus 7 is 25.
Okay, so right here you're going to put 25 on the left side. And then bring down your equal sign. And what's on the right side?
25.
25. So what does that mean? Is that true or false?
True.
True. So what does that mean about p? What did you just find?
Oh,
What's your solution?
that's why I don't like my problems.
That's okay. What'd you plug in? What'd you substitute?
I substitute p with 7.
And did it work?
Yes.
So what does that mean about p equals 7? Is that true or false?
Yes, it's true.
So can 13 work?
No,
Why not?
because it would go over 25.
Okay, let's double check it though. So go over here and put 18 plus p
18 plus p.
equals 25. And what are you going to substitute this time?
With p, 13.
With 13. Good. Equals 25.
25.
What is 18 plus 13?
18 plus 13 is 31.
31. So 31 on the left side equals 25. Is that true or false?
No.
False. See, I like how you crossed off the equal sign. So this is false. So this one's not the solution, right? This one is the solution?
Yes.
Okay, but it said, what does it mean? So it said, tell what the solution means. What does 7 mean? Is that the number of turtles that Terrence needs?
No.
What is 7 then?
7 is the amount of points
Good.
that he needs
To win the game?
Yes.
So 7, he needs 7 more points
to
to
win the game.
You got it. Nice job, Samantha. Perfect. Back to you, Mike. There's some math right there.
All right, thanks for that, Marty. Well, we do have phone tutors available until 5:30, and like I said, the race is getting tighter and tighter as the time goes by for the 5th grade call-in contest. We've actually got 3 schools, but one of the schools has 2 classes now getting close in on the 5th grade call-in contest. All right, I'm going to have you 2 work on a problem together, so both of you head to the board.
Okay.
And I need you to write down, you're going to write down a couple of lines of information, all right?
Okay.
So 1 equals 5,
Okay, I got that. I think I can do that.
2 equals 25, 3 equals 125,
Oh, I know what this is.
4 equals 625, 5 equals question mark. Now, I would like the both of you to collaborate and see if you can come up with what you think 5 is equal to.
Exponents?
And explain kind of how you're getting there.
Or squaring by,
So this doesn't really mean 1 equals 5. It just means that the first number is 5, and so you're looking for the fifth one. So it does look
Yeah.
like 5, and it looks like multiply by 5,
yeah,
multiply by 5
5.
again, multiply by 5 again. So I
so
guess
we
should try
multiply
multiplying by 5
5 again. So we have 25, we have 12, 31. Is it 3,125?
No.
No. Did I multiply wrong?
So let's see.
Huh.
You said exponents, so let's see. We said 5 to the first
Is 5
and 5 to the second
is 25.
and 5 to the third. That's 5 times 5 times 5. But this is 5 to the fourth because that's 25 times 25. And so this should be 5 to the fifth power, right?
Right.
And that's not the correct answer?
No, that's not the correct answer.
3125?
No.
Okay.
So is there a different pattern that you're looking for?
Possibly.
Okay, I see 5555. I see 2222. So what if we try this pattern? Put a 5 there and a 2 there. And let's see.
It goes
No,
1
but
and
there's
6.
a 6
Yeah.
and 1, so that doesn't work.
All right.
Can't see.
Erase your exponent stuff over there.
There, hold on, I
You
got
guys
it.
moving it all around, but.
There we
All
go.
right, let's take a look at this. Let's not. I see how you started, which is exactly why I gave you this problem.
Okay.
All right. Read the first line.
1 equals 5?
Okay. Now, if 1 equals 5, what does 5 equal?
Well, if 5 equals 1, I would say 5.
There you go.
If 1 equals 5, then 5 equals 1.
There we go. It's just that kind of a little riddle thing like that. So if you look at it, if 1 is equal to 5, 5 therefore must be equal to
1.
1.
1.
Well,
Oh, come
see-
on, Mary Lou. Don't give me that kind of look when we're doing this right here. I know exactly what you were doing, which is why I wanted to present that problem like that.
So my question was, what you were saying is, was she writing down what you're saying, and was there really equal signs in there when you said that?
Right.
Okay.
So that's the whole point of that, right? So 1 equals 5, so therefore 5 must equal 1.
1.
That's only it. No, never mind.
You get so just a little thing right there. Okay. So Mary Lou, stand on the board, erase the
Okay.
board.
That was a good one.
This will be a little bit more straightforward.
Okay.
You borrow $1,500 for a year.
Okay.
The interest rate is 26.8%.
26.8. All right.
We want to know the amount of interest you will pay.
Okay. For 1 year, my
Correct.
time is 1 year?
Yes.
Okay. So we're dealing with what's called simple interest. And I always tell my students, hey, when you get after 18 years old, you're going to have to start borrowing money for maybe your car or for school or things. When you borrow money, you go to the bank, hey, I need to borrow money. Sure, we'll let you borrow money, but you have to pay us an interest rate because we want to make money off of whatever you're borrowing. So there's a formula to figure out what your simple interest rate is. And it is I, which is our simple interest rate, is going to equal our principal, we call that P, the principal being the amount you borrow, or if you're depositing money into an account, times your rate, which is our percent, times our time, which is in years. It's always in years. Well, here we're going to put together what information we have. We have our principal. We have the amount we're borrowing. That's our $1,500. We have our rate, which is 26.8%, which we do want to change this to a decimal before we multiply. So again, it's going to be 268 thousandths times our time, 1 year, to find how much simple interest we're going to be earning at the end of that 1 year.
And I'm going to help you out with that using
Awesome.
a calculator that will come out to 402.
402. So that tells us at the end of 1 year, not only do you have your $1,500, But yes, you also owe an additional $402.
And the key is to make sure that when they answer it, it's $402, not $1,902.
Yeah, that's the key, because you have to see, are you asking for the balance or are you asking for just the interest?
All right, nicely done on that. Final time, let's head back out to Williams Elementary and Marty.
7, 8, 9. Sorry.
And I think they've got already out there.
Oh, I'm sorry. Yes,
punchline
we're
to a
here. We were
joke.
doing some division of fractions. So we were in between our breaks. We were doing some division of fraction. I gave them 6 divided by 2/3, which was like a bonus problem. It was really super hard. And we were just breaking up 6. We have 6 whole pizzas, and we're breaking them into thirds, all of them, and then shading in however many 2/3 we can have to fill up all 6 pizzas. And we realized we were just having an argument about that's 2/3, but we were wondering if we could put those together and if that would actually make 2/3. So if we rip those out and put them in their own pizza, it actually does make 2/3. So that does count as another 2/3. So we counted them all up. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 2/3 that fit into 6 total pizzas. So my answer was 9, which is really tricky. But they were actually learning something new. I don't think they've done division of fractions yet. So now when they go back to class, they're going to be like, yeah, division of fractions, I got this. So there we go. And what I want to show you right now is we got our 2 girls who are up here first. How are you guys doing? Say hi.
Good.
We got your shirts. Show off these beautiful shirts. Look how amazing these are. Hold them up. They've got their fabulous Do the Math t-shirts. And I just want to say thank you so much to you ladies for having us out and for doing some math. And I want to say thank you to Bill L. Williams Elementary for having us out. Thank you guys very much for that. And the class, thank you guys so much for doing an awesome job with division of fractions. So yeah, I'm glad you guys had fun. I'm glad you guys learned something. And back to you, Mike.
Thanks for that. We do have a half an hour left for today. End of the 5th grade contest. Let's find out who's going to see the Condors.
All right, and it is Esmeralda.
All right, from Williams. There you go. Congratulations, Esmeralda from Williams. Be going to see the Condors. 4-pack right there. All right, until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern County Water Agency, Southern California Edison, Kern Schools Federal Credit Union, and Panama Buena Vista Union School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.